Now, for this function, okay, so here arc sin, okay, arc sin x. So the derivative of sin, arc sin, okay. So the dx arc sin x, okay. So the derivative of arc sin is what? Is what? Is equal to 1 by the square root of 1 minus x squared, yeah? So from here we have what? So from here we have 1 by the square root of 1 minus x squared dx equal to arc sin x plus c, yeah? Yes. Plus c. So this is the first one. So the second one is d dx, the arc cosine x, okay? Arc cosine x. Arc cosine x equal to what? Equal to minus 1 by the square root of 1 minus x squared, yeah? So here tell us that minus 1 by the square root 1 minus x squared dx equal to what? Equal to arc cosine x plus c, yeah? So of course you can take out the minus here, so it's also equal to what? Also equal to arc sin x plus c, okay, minus arc sin x plus c, okay? Because what? Because we have arc sin x plus arc cosine x equal to 1/2 pi, okay? Equal to 1/2 pi. Arc sin plus arc cosine equal to 1/2 pi, okay? So here, this is the second. So for the d dx, the arc tangent, okay? So arc tangent x equal to what? 1 by 1 plus x squared, yeah? 1 by 1 plus x squared. So here tell us that 1 by 1 plus x squared dx equal to what? Equal to arc tangent x plus c, okay, plus c. So here also the d dx, the arc cotangent, okay, arc cotangent x equal to what? Arc cotangent x equal to minus 1 by 1 plus x squared, okay. So from here we have this, the antiderivative of minus 1 plus 1 by 1 plus x squared dx equal to what? Equal to arc cotangent x plus c, okay? So actually you can here is minus 1 moves through the integral sign. So it's also equal to what? Equal to minus arc tangent x plus c, okay? Plus c. Because here we have what? Because arc tangent x plus arc cotangent x, okay, is also 1/2 pi, okay? It's also 1/2 pi. So here, this four formula, okay? So actually you just need to remember the number one and number 3, okay? So here we have 4 formula, okay? You just need to remember number 1 and number 3. means number 1 and number 3, okay?
Yeah.
You just need to remember number 1 and number 3. So here we have a question, for example, for here, if here is not 1, okay? If here is not 1, for example, here is 3, or here is 5, so what's the antiderivative? So here now, so find the antiderivative of this part, of this. Here is 1 by the square root a square minus x square dx. Here is a greater than 0, a greater than 0, okay? So this is the first one. So the second one is find the antiderivative of 1 by a square plus x square dx. Here is a not equal to a greater than 0, okay? So for these two antiderivative, so how to find the antiderivative of these two? So here now we can see what's the difference of this one and this one. So what's the difference of this one and this one? So here is 1, here is a square, yeah? So here I hope that here is 1. Okay? So here we can write this one. This one actually equal to what? Equal to 1 by the square root a square. We take out a square. So here is 1 minus x square by a square. Yeah? So they are the same. Yeah? So here, for this one, okay, for this one here we can take out. This one we can take out a square root. So here is 1 by the square root of a square times 1 by the square root of 1 minus x by a square dx. Yeah? So here 1 by the square root of x, a square is what? Is a, yeah? So here it actually is 1 by a, the square root of, here is 1 by the square root 1 minus x a square dx. Yeah? So here we need to define u equal to x by a, okay? So here we let u equal to x by a. So du dx equal to what? Du dx actually equal to 1 by a, yeah? 1 by a. So du equal to what? Du equal to 1 by a dx. Or what? Or dx equal to what? Dx equal to a du, yeah? A du. So here equal to 1 by a, just antiderivative of 1 plus the square root 1 minus u squared, yeah? And dx equal to what? Dx equal to a du, yeah? So we replace dx by a du. So here we have a cancel, yeah? Cancel. So actually here is 1 by the square root 1 minus u squared du, yeah? So here this one equal to what? Arc sin, yeah? So here is what? Arc sin u. Arc sin u plus c, yeah? U is what? U is x by a. So we replace u by x by a, yeah? So arc sin x by a plus c, yeah? So this is the first one. So what about the second one? The second one actually is the same, okay? So we take out the a square. We take out the a square. So here this one, okay? For this one, here is we take out a square Here is 1 plus x squared 1 dx. Okay? So here is a squared, we take out a squared. So here is 1 by a squared. Here is 1 by 1 plus x squared by a squared. So dx. So it's the same, yeah? So we let u equal to x by a. So here is 1 plus, so here actually is what? Is 1 plus u squared, yeah? So here should be u squared, and dx equal to what? Dx equal to a du, yeah? So here is a du, yeah? Here we have a, here we have a squared, so we cancel a, 1a, so here is 1 by a, yeah? 1 by a, the antiderivative of 1 by 1 plus u squared du. So here is what? Here is 1 by a, here is what? Arc tangent u, yeah? Plus c, yeah? U is what? U is x by a. So the result actually is here. So now for this part, okay, we can see page 283, okay? 283. Now let's see 283 example 13, okay? Example 13, okay? So the antiderivative of 1 by a squared plus x squared, okay?
This way, you're right.
This one.
Yeah, just give us 2 minutes to finish it.
What?
I'm saying you need that way before we go to the example in the book. Right. Because right here on this thing.
So this part is for here. This part is for this one.
Yes. So just give us 2 minutes to finish it.
So here we can see the example 13, and the formula number 5, number 6, number 7. Okay. And example 14. Okay, example 14. So here we give 2 examples. Okay, we give 2 examples. Now let's see these 2 examples. Okay, these 2 examples. The first one is the antiderivative of 1 by the square root of 2 minus x squared. Okay. So here, actually here we can see if here 2 is 1, okay, we can find the antiderivative. So here, I hope here is 1. Okay. So we take out 2. Okay, we take out 2. So here equal to what? So here equal to 1 by the square root. So no. I think that you do the exercise, okay? Now do the exercise these 2. Do these 2 exercises now, okay? Now, okay, let's see. So here for the first one, okay? For the first one, here equal to what? Here equal to 1 by the square root. So here is 2. So we take out 2, okay? We take out 2. So here's 2 times 1 minus x squared by 2. Yeah? So here dx. Yeah? It's like this, yeah? So the square root of 2, so we take out square root of 2. So here is what? Here is 1 by the square root of 2, yeah? So here is just the antiderivative of 1 by the square root 1 minus x squared by 2. We write it by x by the square root of 2, the whole square, yeah? So dx is like this, yeah? So now we let what? We let u equal to x by the square root 2, yeah? So here we let u equal to the x by the square root 2. So here du equal to what? Du dx equal to what? Du dx equal to 1 by the square root 2, yeah? So here du equal to what? Du equal to 1 by the square root 2 dx. Or dx equal to what? Or dx equal to the square root 2 du, yeah? Yeah? So here now we have what? So here is 1 by the square root 2. Here is the antiderivative 1 by the square root 1 minus u square, yeah? So dx equal to what? Dx equal to the square root 2 du. So here is the square root 2 du, yeah? Square root 2 cancel, yeah? So here is equal to what? So here is arc sin u plus c, yeah? We replace u by this x by square root 2. So the result is arc sin x by the square root 2 plus c. Okay? So this is the second or the first. So the second here is the same, okay? U here is e to the power x, here is e 2x power, okay? So here is what? So here is ex, here is the square root e 2x power. Actually, we can rewrite it in 1 minus ex to the power 2 square, yeah? So dx. So here actually it's easy. So we let u equal to what? U equal to ex, yeah? So we let u equal to ex. So du dx equal to what? Du dx equal to ex, yeah? So here du equal to ex dx. Or dx equal to 1 by ex du, yeah? So here we replace, so here is ex, here is the square root of 1 minus u square. Of course, okay, of course, you can replace ex by u, okay? So here, dx we replace it by 1 by ex du, okay? So ex cancel. So here is ex. So here ex cancel. So here is 1 by the square root of 1 minus u square du. So the result is what? So the result actually here is arc sin u plus c. We replace u by ex. So the result is arc sin ex plus c. Okay. So this is the result. Now this is the end of chapter of 6.3. Okay, 6.3. But here now all students, okay, all students see page 284. 284, okay? 284 here, we have many antiderivative, okay? Use substitution. So I give you a suggestion, okay? All of you to do the exercise number 1 to number 15, okay? Page 284, okay? Number 1 to number 15, okay? You do the exercise. Okay? You do it. If you have any problem, okay, you can find me at Tuesday night from 8 p.m. to 10 p.m. My office, okay, 623, okay, 623. So, because this part is very important, okay? This part is very important. the anti-derivative is 1 equal to. So I hope that all of you can familiar with it, okay? All of you can familiar with it. Now we go to the 6.4, okay, 6.4. But before the 6.4, we introduce a notation, okay? We introduce a notation. So here, for example, the notation is means the sigma, okay? Sigma. Okay, sigma means what? Means the summation. Summation notation, okay? Summation notation, for example, 1 plus 1 square plus 2 square plus 3 square plus 4 square plus 5 square, we can rewrite it use sigma, okay? We can rewrite it by sigma, so it's written by sigma k square, k from 1 to 5, okay? So here, this notation, okay? This notation means the sigma notation. Or the summation notation, okay? Summation notation. So here, this sigma means the summation notation, okay? So here, for example, we have this sigma. This, okay? Here, k means what? K is the index of summation, okay? Index of summation. K is the index of the summation, okay? And the 1 is what? 1 is the starting value of k, okay? 1 is the starting value of k, okay? Or what? Or the low limits of summation, okay? Low limits of summation. And the 5, okay? 5 actually is the end value of k, okay? 5 actually is the end value of k, or means the lower or the upper limits of the summation, okay? So here, k square, okay? K square actually is the term of the summation, okay? The term of the summation. So here, for example, for the summation, okay? For the summation here, we can write it in this form, okay? In this form. Summation or sigma k equal to m. K equal to m to n, okay, to n. Fk, okay. This summation, okay. This summation means what? This summation means equal to fm plus 1 plus fm plus 2 plus fm, okay? So here, in this notation, here k is the index of summation, okay? So index of summation. index of summation, and M, okay, M is means what? M is the starting value. Starting value of K, okay, or what? Or the lower limits. The lower limits of summation, okay? And the N is what? N is the ending value. Ending value of K. Or what? Or the upper limits. Upper limits of summation. Upper limits of summation here. And Fk, okay? Fk is what? Fk is the term, okay? The term form. Fk is the term form, okay? So the each term, the form of each term, okay? Each term. The form of each term. So of course, sometimes we not write here Fk. Fk actually is a function of K, okay? Sometimes we will write here another Fk. Sometimes we write it in, for example, sigma K equal to from M to N, okay? From M to N, here is AK, okay? AK. So here is the same, okay? Here is equal to what? Equal to AM plus AM plus 1 plus AM plus 2 plus AN, okay? AN. So here for this one, okay? For this one, so this, for example, this one, read, okay? How to read this notation, okay? This notation means that the summation of AK, okay? The summation of AK YK runs from N to N, okay? So here, how to read this notation? This notation means that the summation of AK, okay? The summation of AK, YK runs from M to N, okay?
Yes.
So here, for example, I give some example for this example. Sigma K equal to 4 to 8 K cube. So the summation of K cube YK runs from 4 to 8. So this is equal to what? This notation is stands for here equal to what? 4 cube plus 5 cube, yeah, plus 6 cube plus 7 cube plus 8 cube, yeah.
Yeah.
So this notation means here, okay, means here. So the first one, now for the second one here. So the summation of 2k YK runs from 1 to 5. YK runs from 1 to 5. Okay? For this one, what? So this actually is what? is 2 times 1 plus 2 times 2, yeah, plus 2 times 3 plus 2 times 4 plus 2 times 5, yeah? So actually it's what? It's 2 plus 4 plus 6 plus 8 plus 10, yeah? So here is the second. So what about here? The summation of 2k plus 1. Yk runs from 0 to 5. Yk runs from 0 to 5. Okay? For this rotation actually means what? This rotation actually means here is 2 times 0. 2 times 0 plus 1, yeah? Plus 2 times 1 plus 1, yeah? Plus 2 times 2 plus 1, yeah? Plus 2 times 3 plus 1, plus 2 times 4 plus 1, yeah? And plus 2 times 5 plus 1, yeah? So here equal to what? Here equal to, here is 1 plus, here is 3 plus 5 plus 7 plus 9 plus 11, yeah? So here, the same, okay? So the summation of minus 1 to the power k times 2k plus 1, yk runs from 0 to 5. So what's for this one? Okay, for this one. So the summation of minus 1 to the power k times 2k minus 1 plus 1. Yk runs from 0 to 5. Okay. So here, actually here is what? So minus 1 to the power 0 times 2 times 0 plus 1. Yeah. The first one. The second term is minus 1 to the power 1. 2 times 1 plus 1. Yeah, so the second. So the third is minus 1 to the square. 2 times 2 plus 1. Yeah. And plus minus 1 cube. 2 times 3 plus 1. Yeah. And plus minus 1 fourth power, 2 times 4 plus 1. And here is plus minus 1 to the 5 power, times 2 times 5 plus 1. Yeah? So here minus 1 to the 0 power is 1. Yeah? 1 times 1. So the first term is 1. Here is 3 times minus 1. So 1 minus 3. So here is minus 1 square, 1, 5, 1 times 5. So 1 minus 3 plus 5. Actually is minus 7 plus 8, 9, minus 11. Okay? Like this. So I will write.